e. We're going to do the same thing. They give us u. We want to evaluate this integral twice. Once where our u is going to be 5x plus 8, and again where u is the square root of 5x plus 8. Okay. So in the first case, then du would be 5 dx. And in this case, where u is basically 5x plus 8 to the 1/2 power, then we can say that du, the derivative of that would be then 1/2 5x plus 8 to the negative 1/2 times 5 dx. Or kind of consolidating it a little bit, it'll be 5/2 5x plus 8 to the negative 1/2 of dx. Okay, so now let's go with part A first. Let's get started with that one. Or the fact when u is 5x plus 8. We can maybe call this the number 1 of it. Okay, so if u is 5x plus 8, then it's sitting right in there. And then du needs to be 5 dx. So I need to then put a 5 in there, which I'll just put in the top, over the square root of 5x plus 8. And if I put a 5 in the top, then I've got to counterbalance it out front with a 1/5. Okay, so we're looking at then the 1/5 times the integral of du over the square root of u by the time I do my substitutions. Or looking at it, it's the integral of u to the negative 1/2 du. Because remember, square root's the 1/2 power. If I put it all in one line, take away the fraction, then it'll be a negative 1/2 power. Okay. Well, we have a rule for that. We're going to add 1 to the exponent. So it becomes a positive 1/2 and divide by the new positive 1/2. Oops, I forgot the 1/5, didn't I? Let me put that in there. And then we want to add, of course, never forget r plus c. Okay, so kind of cleaning this up real quick before I put my substitution, my u back in. That'll be then a 2/5 u to the 1/2 plus a 5th times c is just another constant. So all in all, then my answer will be 2/5 u, which is 5x plus 8, all of that to the 1/2 power plus c. And since it was in the terms of a radical, if we wanted to keep it as a radical, it'd be 2 square roots of 5x plus 8 all over 5 plus c. Okay, so now that we've got that answer, let's see about if anything changes when we go about it the other way, when we let u be the square root of 5x plus 8. Okay, so now on to part 2, where we're going to make a different kind. We're going to focus on with u being the square root of 5x plus 8. Okay, I want to show you guys something. I'm going to do it 2 ways. One way is going to be totally illegal, but then there's a second way to show you how we're going to counterbalance this. Because the first way, you're kind of like, oh, that's initially how I'm going to do it. Alright, so if I go in there, and first of all, it looks like we're doing the integral, and then down here in the denominator would be just u, right? Because u is going to be the square root of 5x plus 8. Well, then I need the top. I need to replace dx, which is this. I need to incorporate all of that in the top, so that way I get just du. So if I put the 5/2, and then I wrote it as the 5x plus 8 to the negative 1/2 dx. Okay, so if I put all of this, basically this big front part in there, then together all of this is my du, right? Well, if I add in this whole front part to the top, remember how I say we always have to do the kind of the opposite out front, so that way we can counterbalance it. So it'd be 2, and then the 5x plus 8 to the positive 1/2 to counterbalance all of that. Okay, so looking at this, it looks like it'd be 2 times the 5x plus 8 to the 1/2 over 5 times the integral of du over u. Now, this right here is where notice the big controversy going on. Outside the function, I've got x's. Inside the function, I have u's. And there's a big mistake that's happening here. You see this wonderful variable? You can never ever pull a variable across the front of an integral. You can only pull constants out front. So like if you were going to take the integral of 2x cubed, you can pull the 2 out front and write it as 2 times the integral of x cubed, but you can never pull variables across the integral sign. Okay, so that right there, I wanted to show you guys that. So we got to think of something else on how we're going to solve this integral. So let me erase all of this real quick. and we're going to go, so this was all the legal way, but I really wanted to show you that just for that point, if you can ever pull a variable out front of that integral sign. Okay, so let's change it to this now. Let's go up into this main function, and let's focus on more of anything finding our du part. So when I come over here to the right, I could really write du as being 5 over 2 times the square root of 5x plus 8, right? Or, and then dx, or I can write it as du is equal to, so I can show you this, 5/2 times dx over the square root of 5x plus 8. See if y'all agree that this is really what du is. Well, if I go to my function up here, look, all of that is what's already given to me. So all I have to do is, if I can put 5/2 inside this integral, then I have du. So I can write this really as 5/2 times du, and if I added a 5/2 in the front, then I've got to do or 5/2 inside here, then I've got to do a 2/5 this way. Or actually, so this makes even just more sense, let's go with this one. Now that I'm looking at it a little bit more, let's write this as the fact that what I boxed in here, I can write it as, let me move that 2/5 over. Get ourselves some more room. 5x plus 8. So all of this right here, I can replace with 2/5 du. So all that box, which is what was given to me, I'm going to replace it with 2/5 du. There, and that's a little bit more easier because I'm going to replacing it exactly 1 for 1. Okay. And now, since just a 2/5 is out front, I can pull that across, and all I'm looking at is the integral of du. Well, the integral of du is just u. And when I make that substitution in of what u was, it's just 2 times the square root of 5x plus 8 all over 5. And by doing that, we actually get the exact same answer as we did for the first part, which you should always do. No matter how you take the integral, all this is asking you for is what is the area underneath that curve. So whenever, no matter what you replace u with, whether you did u with 5x plus 8 or u with the square root of 5x plus 8, you should always be getting the same answer either way. Okay, so I guess this is my hint, is when you go throughout a process and you find yourself wanting to pull a variable across that integral sign, stop, go back, and the best thing you could ever do is try to substitute du first before you substitute u. You do not always have to use u. You don't ever always have to use u. It's just always try to get the du part first and then see if you have u left over. Okay? All right, let's go on to example 2. Starting out here in example 2, what they want you to do is now you have to decide what you want u to be, and then you have to find du. Okay? So instead of already kind of guiding you through that process, you're going to do it your own. Okay, well, first thing I think of when I look at this problem is I've got something raised to a power. So I'm just going to try it out. You never know. This is a lot of just kind of a trial and error process, but let's let u be 1 plus the square root of x. Okay? So if that's the case, then du is obviously going to be 0 plus, and that's going to be 1/2. Remember, we're on the 1/2 power, and then x to the negative 1/2 dx. Or we can see du as being 1 over 2. I bring that down, it'll be the square root of x dx. All right, well, do you recognize du in here? There's the 1 over the square root of x. All I need is to put a 2 right there. And if I pull a 2 right there, then I'm going to counterbalance, since this is a 1/2, I'm going to counterbalance it with just a regular 2 out front. Because 2 times a half would take that back to original function. Okay, so let's make this substitution and see what we've got here. So we're looking at 2 times the integral. The 1 over 2 square roots of x dx part is going to be du. And in the denominator, I have my u squared. Okay, so this is 2 times the integral of u to the negative 2 du, which is going to be 2 times, we're going to add 1 to that exponent, divide by that new exponent, and then plus c. So we can write it as negative 2 u to the negative 1, and then just putting back in, or if we, I guess if we want to leave it in terms, it would be negative 2 over u, and then plugging u in would be negative 2 over 1 plus the square root of x plus c. And there's our answer for number 2. Moving along to example 3. Okay, we have 2 parts. We have a tangent squared and we have a secant squared. One part's going to be your u, the other part's going to be the du, the derivative. So let's think. If I start with my u, if I start with my u being a tangent, let's say tangent x, then du, what's the derivative of tangent x? Well, it is secant squared x dx. So that would help, because that way we can take all of the secant squared x and replace it with du. Okay. Otherwise, if I said, let's let u be the secant x, then du would have to be secant x tangent x, right? Gotta think about it there for a second. It's like you have to change your brain. Okay, doing derivatives this time. Now I'm going to go back to integrals. Gotta go back to derivatives. You gotta think about it for a second. But if u is secant x, then du would be secant x tangent x. We could use one of the other secant x's, but then what are we going to do with the second tangent squared? So obviously it looks like maybe the first pairing is what we're going to want to go with for this one. Okay. I just want to show you guys, just to play the what ifs part. Okay. Well, if I look at this integral then, it's saying that if my u is tangent of x, then this is going to be the integral of u squared, and then all of secant squared x dx is going to be my du. So just simply taking that integral there, it's going to be 1/3 u cubed plus c. And then plugging in what u is, it'll be tangent cubed x plus c. And there's our answer for that one. So it's not a really tricky problem. It's just, I think this is a great one to really practice, okay, which one's my derivative and which one's my integral, and making sure I get my rules correct, especially when doing with the trigonometric functions. All right, let's go on to example number 4. We want to evaluate this one. All right, looks like we got some fun try. My initial reaction is, let's let this base, since it's to a power. Usually things that when they're to a power, that's what your u is going to be. So if we say u is going to be 7 minus r to the 5th over 10, that's fun. Then du is going to be, let's take away the 7, so that's 0. So if I pull off the negative 1/10, then I'm just focusing on r to the 5th, so it'd be 5r to the 4th dr. We're cleaning this up then. Du looks like it would be a negative 1/2 r to the 4th dr. Okay, let's see if we can recognize then a bunch of this inside of our function. We obviously got the r to the 4th, that's great, and we got the dr part. So all I need inside the function then is just a negative 1/2, and to counterbalance that, I'm going to put a negative 2 out front. Negative 2 can definitely go there. So I'm going to write this then as negative 2 times the integral of negative 1/2 r to the 4th, 7 minus r to the 5th over 10 cubed dr. So now everything's in place to do all my substitutions. It's going to be the integral with negative 2 out front, that and that, all those together, that's my du, and then I have u cubed du. Okay, so now taking the integral, it's going to be 1/4 u to the 4th plus c. And now my substitution, so negative 2 times 1/4 my u, which is 7 minus r to the 5th over 10, that to the 4th power, and then plus c. So bringing in that negative 2, and we can call this finished. 2, we'll make that a negative 1/2, parentheses, 7 minus r to the 5th over 10 to the 4th, and again, any number, anytime you're multiplying a constant to your c, you just keep it as a c. All right, let's go on to the next one.